Just some notes from section 5.3 on solving polynomial equations. There's two different ways we're going to learn how to solve polynomials. The first we did when we solved quadratics, which is to solve by graphing, and the method's exactly the same. We'll do one example there so that you see how to do it, but there's really nothing new on solving by graphing. And the second is solving by factoring, which we know how to do with quadratics, but we're going to learn a couple of new factoring techniques in section 5.3. So example 1 here asks us to solve by graphing. We're given x cubed plus 2x squared equals x plus 3. To solve by graphing, you always want to get your equation equal to 0 first. So I'm going to subtract x from both sides and subtract 3 from both sides, and my equation is equal to 0. And now we are going to graph the function. So we've got x cubed plus 2x squared minus x minus 3. We're graphing y equals that. I zoomed into my standard graph from -10 to +10 on both the x and the y. And the graph looks something like this. So we've got a cubic there. It's got 2 humps. It goes up, comes back down, goes back up. We graphed y equals this, and we want to solve 0 equals this. So we want to know when is y equal to 0. We are looking for the x-intercepts, the zeros of the graph. We know we have 1 right around here. So we can find that one. We go to calculate, which is second trace. Go to number 2, which is 0. And then you need to tell it 2 numbers to look in between. Left bound, you need to enter something to the left of that x-intercept. I'm going to enter 0. And right bound, you need to enter something to the right of that x-intercept. 2 or 3 or 10. Anything to the right, as long as it's on your screen, should work. Answer, x equals 1.148. Looks like we might have another 0 here. It's kind of hard to tell. It might touch the x-axis, it might not. You can go ahead and try to calculate that 0, second trace, number 2. If there is one, it's in between -4 and 0. Guess, just push enter again. And notice it spits out an error. It's giving you an error because there's not an x-intercept in between there. You could verify that if you change your window and kind of get a little closer to the x-axis. Notice it comes up. Doesn't quite touch the x-axis there, so that we only have that one solution. X equals 1.148 is the only solution. Different ways that we've learned how to factor. We learned lots of different ways to factor quadratics. We're not going to review all those right now. You learned a bunch of methods in chapter 4. As we need them, we'll kind of review them. We did very briefly touch on difference of squares, so I'm going to cover that in a little bit more depth here. The rule for difference of squares, if we have 2 perfect squares connected with a minus sign, so a squared minus b squared, we can factor that by doing a minus b times a plus b. Quick example, a couple quick examples on factoring using a difference of squares. X squared minus 25, those are both perfect squares. 25 is 5 squared. And then the rule is the first one minus the second one. So x minus 5 times the first one plus the second one, x plus 5. And we have successfully factored. Example 3 asks us to factor 9y squared minus 1. 9y squared we could write as 3y. 1 we could write as 1 squared. So our factors are 3y minus 1 and 3y plus 1. So that's factoring by a difference of squares. You did that in Algebra 1. We did it very briefly last semester. Hopefully we're good at ones like that. The two that are new is a sum of cubes and a difference of cubes. So sum of cubes, we have perfect cubes, a cubed and b cubed, with a plus sign in between. Or a difference of cubes, which would be a cubed minus b cubed. And we can factor either of these. The rules are a plus b times a squared minus ab plus b squared for a sum of cubes. And the difference of cubes is a minus b times a squared plus ab plus b squared. So notice all the a's and b's are in exactly the same place. So you don't necessarily need to memorize both rules if you know that it's the first one, second one. And notice this sign right here is the same as the sign that's given in both rules. If it's a plus here, it's a plus. If it's a minus here, it's a minus. And then the second factor is always the first one squared, multiply them together, square the last one. And notice this sign right here is the opposite of what's given. This one's minus when it was plus. If it started as minus, now it's a plus. We'll practice some similar to those. And then the fourth way, which we actually aren't going to cover today, but you'll learn soon, is how to factor polynomials that can be rewritten as quadratics. So they aren't quadratics, but I could rewrite it. I could change it so that it is quadratic. So let's take a look at a couple of these. This one asks us to factor x cubed plus 27. X cubed plus 27. First thing, even before we do this problem, you should start to recognize the perfect cubes. So 1 cubed is 1, 2 times 2 times 2, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, and there's more. 10 cubed you should also recognize right away as a perfect cube. So just like you see 49, and you know 49 is a perfect square right away, when you see 216 or 64 or 125, you should recognize those as perfect cubes immediately. So this one asks us to factor x cubed plus 27. So x cubed, and 27, I can rewrite that as 3 cubed. And then we're going to use the rule for sum of cubes. So sum of cubes, it's the first one, same sign, the second one. So the first one, x, same sign, it was plus, keep it plus, the second one. And then the second factor is the first one squared, x squared, opposite sign, it was plus, now it's minus. Multiply them together, x times 3, plus the last one squared. 3 squared is 9. So again, it's always first one, same sign, second one. First one squared, opposite sign, multiply them together, plus last one squared. Let's try another one here. Example 6. Asks us to factor 8z cubed minus 125. 8z cubed minus 125. 8z cubed we can rewrite as 2z all to the third. 125 I can write as 5 cubed. And then the rule is first one, same sign, second one. So my first factor is 2z minus 5. Second factor, First one squared. 2z times 2z is 4z squared. Opposite sign, it was minus. Now it's plus. Multiply them together. 2z times 5 plus last one squared, 5 squared. That one's example 4. This was example 5, not 6. And then the last problem we're doing here, the title of this section was solving polynomial equations. All we've done is factor them. Just a couple other things we need to do to solve it. So on this one, I want you to pause the video and try to factor it. And then once you think you have factored it, go ahead and play the video. I'll show you how to factor it and how to solve it. So 27x cubed, I'm going to write as 3x all cubed, and 1 is 1 cubed. So my factors, first one, same sign, second one, 3x plus 1. Second factor is the first one squared, different sign, 3x times 1, plus last one squared. So that should be the factors. Once I know I have two factors and they multiply to give me 0, I know one of those factors is 0. So either 3x plus 1 is 0, or 9x squared minus 3x plus 1 is 0. And then solve. This one's easy to solve. Minus 1, divide by 3. This one's more difficult to solve. I would always solve this using the quadratic formula. It is never going to be factorable. It always has imaginary solutions, so solving by graphing's out. Solving by using the quadratic formula is going to be the way to go here. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Four times 9 times 1 is 36. Nine minus 36 is negative 27. Square root of negative 27. Square root of 3 times square root of negative 9. 3i root 3. Top and bottom can both be divided by 3. 1 plus or minus I root 3 all over 6. So to go from here to here using the quadratic formula, we did that last chapter also, so nothing terribly new there. Really the new part is factoring to go from here to here. This part, again, I would always solve by using the quadratic formula. A good way to know that you did it right, these problems for some reason, this will always have an I root 3 in there. So if you get an I root 3, you've got a pretty good idea that you did it correctly. That is section 5.3 on solving quadratics or solving polynomials. If you're having questions on anything, please reach out, let me know.